that involve square roots of expressions. We'll walk through 4 integrals and use completion of the square, substitution, and standard antiderivatives to get clean answers. Here is the first problem. We need to integrate the reciprocal of the square root of parentheses x plus a times x plus b close parentheses. We'll start by expanding and then completing the square. Now, we complete the square. We rewrite x squared plus parentheses, a plus b close parentheses, x plus as parentheses, x plus half of a plus b close parentheses squared minus parentheses, a minus b over 2 close parentheses squared. This matches the form we need to use the standard logarithmic antiderivative. The antiderivative of 1 over the square root of u squared minus c squared is the natural logarithm of u plus the square root of u squared minus c squared. Plugging our expression in, we get the logarithm of x plus half of a plus b plus the square root of the original product. The second problem is very similar. We integrate 1 over the square root of parentheses, x plus 5 times x minus 1 close parentheses. We expand, and then write it as a square minus 9. Then we complete the square. The expression becomes parentheses x plus 2 squared minus 9. That, again, matches the form u squared minus a squared. The antiderivative is the log of x plus 2 plus the square root. So the antiderivative is the natural log of x plus 2 plus the square root of the original product, plus the constant. Next up is problem 8 part 1. Integrate the square root of parentheses, a plus x over a minus x. We'll rationalize that radical by multiplying top and bottom inside the square root. Split the integral into the sum of over root, a squared minus x squared, and x over that same root. The first is a times arcsine of x over a. The second uses substitution, giving minus the square root of a squared minus x squared. Finally, problem 8 part 2 asks for the integral of the square root of 1 plus x over x. Multiply top and bottom inside the square root, so we get 1 plus x over the square root of x squared plus x. Split the numerator into 1/2 times 2x plus 1 1/2. The first piece gives sqrt of x squared plus x via the substitution u equals x squared plus x. The remaining piece produces 1/2 times the logarithm of x plus 1/2 plus the square root. The final answer is the square root plus 1/2 the log, both involving x squared plus x. We completed each integral by matching the structure inside the square root to a known antiderivative, and by smartly separating the numerator when necessary. Keep practicing these techniques so that these square roots